we have already done this integration. We have done. Now here, if I take x raised power n as first function and these two as or integration second function, okay, the integration of these two we are. Let me check that what is the integration of these two. This which is, let us do, which is as follows. Let me integrate these two by parts. Integrating this by parts. Integrating this by parts. We get, now in these two functions we can take either Eilert formula or without Eilert formula. If I take sin bx as first function, this as second function, or ex as first function, this as second, doesn't matter. Let me first take sin bx by the rule of Eilert. Let me do this by Eilert formula. This is Eilert formula. E is the last function, second function. Trigonometric function is the first function. First, second, first, second, first, second, first, second, first, second. Trigonometric function, first function. Exponential function as second. Let me do this in this way. Integrating it by taking this as second function, this as first function. We have done this also by considering this as second function, this as first function can also be done. No doubt about this. Okay, so both techniques can be used. Okay, that is not a matter of discussion. Let me take this as first function which we are following this rule. So integration of this will be sin bx first function as it is. Therefore, this, let me take this is only I, because I b we cannot take. Let me take here sign of integration. Okay, sin bx b raised over ax into dx is equal to sin bx first function as it is. Integration of second, this is eax upon a minus sin. Differentiation of sin bx is cos bx, but into b. Cos bx it will be into e raised over ax upon a into dx. Okay, again let me integrate it, but we have to achieve sin bx. Till then we have to integrate it. Let me further integrate. This is, let me write here, this is b upon a. Let me further write as this is sin bx b raised over ax upon a. This is minus b upon a sin of integration. This is cos bx e raised over ax. This is dx. Let me take this as first function. Now integrating this part by parts again. Integrating the sign of integration and the integral just cos bx e raised over ax into dx is equal to, again taking cos bx first function, ex second function. Let me integrate this. What do we get here? We will get cos bx as it is. Ex is ex upon a minus plus it will be. It will be plus here. Why? Because cos bx will be minus sin bx. Differentiation will be b into sin bx into e raised over ax upon a into dx. By parts. First function as it is, integration of second, that is ax upon a. Now plus differentiation of first, which is cos bx, that will be minus sin bx into b. We are taking, but minus plus, because anyway we keep minus sign by parts rule. In by parts rule, we keep here minus sign, but because minus sign will come from cos bx. Cos bx is differentiated as minus sin bx into b. That is there. So this is, let me again solve it. This is cos bx b raised over ax upon a. This is plus b upon a into sin of it. This is the same function sin bx b raised over ax dx. Now if I substitute this is second equation. Now from second, if I substitute in the first, what do we get? Let me write it here. Finally, we get integration of this function as sin bx ax upon a, this one, minus b upon a, we were multiplying with this. Okay, so this is in place of this is b cos, sorry, integrated as b upon a square. So here it is cos bx only, e raised over dx, b minus sin, this minus plus, so it will be minus sin again, it will be minus sin. Now b upon a, while there, b upon a into b upon is e square upon a square, b square upon a square, sine of integration, sin bx and 3x over dx, dx. The same function which we started with. Okay, so finally what do we get? The integration of this function, therefore will be integration of this will be taking this to this side will be a square plus b square upon a square. This is 1 plus b square upon a square, sum of integration sin bx eax. Okay, eax into dx is equal to this value. This is sin bx eax on a minus sin. This is b, sorry, b upon a. This is b upon a square. B upon a square into cos bx eax only. Now if I divide it by a square, b square and a square cancelled out. Here if I write a and this is a square, a square, a square, a square cancelled out. This is nothing but a square upon a square, this a square cancelled out. Now of integration sin bx e raised over ax into dx is equal to this value a into, let me write test, remove this, only a square b square will come in the denominator, b a into sin bx, so let me take ex common, with a sin bx minus b cos bx divided by a square plus b square. This is value of sin x ex dx. Now if I suppose take a equal to something, r or b equal to something, if a is equal to r cos theta, b and b is equal to b, we are assuming this r sin theta, then for sin alpha let me take it is a and b, so let me take alpha here, this is alpha, then what it will be, then a square b square is equal to r square whole square, squaring these two, b r square cos square alpha plus r square sin square plus cos square equal to 1. So a square plus b square into r, or r is equal to the root a square plus b square. If I substitute here, a is equal to something, which is that, what is that? R cos theta, R cos alpha, sin bx, it will be sin a cos b minus cos a sin, which is cos a, sorry, sin a minus b. And this is a r square, but r is a common from here. It will be r into e raised over ax. In bracket it will be, that means r taken out. It will be, sorry, it is sin bx cos alpha minus cos bx sin alpha, okay, upon r square, r cancelled out. This is what we have got, eax. This is nothing but sin bx minus alpha, because if I open this, sin a cos b minus cos a sin bx alpha is, from there we can obtain ex upon r here, only r is under root a square plus b square type ones, and where alpha is equal to, where alpha is equal to tan inverse b upon a. Right, understand? This is b upon a. So this upon this is tan alpha. R sin alpha upon R cos alpha is tan alpha. But b upon a, it is alpha, it will be therefore tan inverse b upon a. Alpha is here tan inverse b upon a. This is the integration of these two parts. Integration of these two parts. Okay, so therefore we can now substitute integration of this whole. Therefore, from this integration, what do we get? Therefore, integrating it by parts, integrating it by parts, taking x over n as first function, and ax sin bx as second function, then integration of this whole will be what? First function x(n) as it is, integration of ax sin bx dx minus sign, differentiation of this, it will be n into x over n minus 1, differentiation into integration of the same way, sin bx ax dx whole dx. What happened? Now what is this value? Therefore, in place of integration of this, we can substitute this here with the final value. Therefore, this is xn into ax upon under a square plus b square sine of bx minus alpha. Okay, this is integrated minus sine n into x over n minus 1. Same integration. Okay, upon under root a square plus b square. Constant can be taken out. It will be e raised over ax into sine. Well, inside, so it is integrated. Or ax sin bx minus alpha. It is to be further integrated. Okay, this is reduced formula because x over n minus 1 has come out. This is how we can keep it as reduced formula. So this is reduced formula for second part. And question number third. Question number third is therefore integrated like this. Now if I take the fourth question, which is of the similar type. Now again we have to integrate here ax cos bx we have already done. But here in this case, what it will be? Cos A cos B, okay, plus sin A sin B. It was minus sin A sin B. So it will be cos bx plus alpha. Okay, just in place of this sin bx plus minus alpha, we will have cos bx plus alpha. This is the only difference, otherwise the same thing will happen. We can get therefore question number 4. Similarly, integration of x over n ax cos bx dx will be equal to x over n first function as it is, integration of these two by parts ax sin cos bx will be ax upon under root a square plus b square. Now it will be cos a minus b, sorry, cos a plus b is cos a cos b minus sin a plus b. With angle will be plus, it will be cos of bx plus alpha. This is the integration of this. Well, we have first function as it is, integration of these two. Integration of these two with this, which we have already calculated like this. Single function will be obtained like this. It will be only plus sign here. Why? Because cos a cos b, we will have r cos alpha into cos bx plus r sin alpha minus sin and then plus sin. It is in between minus sin minus r sin alpha into sin bx. That means r taken common, that is upon r square by there, so it was bx upon r. So r is under a square b square. It will be cos alpha into cos bx minus sin alpha into sin bx. That means this is cos A cos b minus sin alpha. Formula is from trigonometric identity. Cos A plus b, cos A plus b is cos A cos b minus sin is sin. If it is plus sin, then it is minus sin minus plus. It is in case of cos. This is the integration of this part. Here it was in sin. In case of sin, it was bx minus alpha. Only this is the difference. Bx plus alpha. Same thing other. Okay. Minus sin is n upon 2. Under root a square plus b square will take out. Then x is for n minus 1. This is reduced formula because this is reduction formula. How it is? What degree is reduced to n minus 1 into ax cos bx plus alpha into bx, where alpha is equal to tan inverse b upon a, this is b upon a. Okay, this is r here, r is under root a super this. This is the reduction formula for question number 4. Right one is question number 4 is done. Third, similarly, third and fourth. These two are similar. You have to just keep this in mind. But what is the positive or negative sign on the plus sign? Okay. Here it is minus sign. Here I think it's also minus sign. Not a great point. Okay, so this is integration. So question number 4 is done. If there is a negative positive sign, then we just keep. If numeric questions are there, we can solve it very easily. But I will take the fifth question and the sixth question. They are all similar type. First question, let me take the fifth one. Then similarly, we will say we will calculate sixth one also. Here the two other reduction formulas. This is the reduction formula for question number 4, and this is third one. So we have done 4 questions here. Let me take the fifth question. What is the reduction formula for fifth? Let me check it. Question number 5 here. Okay, so question number 5 says sign of integration. This is positive power mx into sin mx into dx. Again, this power is to be reduced, so we will take it as first function. Now there are both trigonometric functions. Which one is to be taken as first function, which is to be taken as the second function? That is the question of discussion. Just try to understand that we have to reduce the degree. The reduction of degree is done only in case of differentiation, not in case of integration, because in integration, powers are added. One is added in the power, so it is increased, not decreased. But we want reduction formula. Therefore, this power function cos n raised power, cos raised power n. Okay, this is to be taken as first function for reduction. Degree only then can be reduced. Let me take integrating this by parts. Integrating it by parts. Considering cos raised power n bx mx mx cos raised power mx as first function. Here, cos raised power nx as first function. As first function, and sin nx as second function. As second function, we can represent it as im nm or imn. This is imn here. Imn, we can represent this as second function. So we get here, let in is continued. Thereby it is imn, because mn we have got. So with this imn, sign of integration, cos of n sorry, cos of nx sin nx dx. Okay, so integrating it. Therefore, integration of this will be cos raised power nx as it is. Integration of sin nx will be minus cos nx upon n. Try to understand. Integration of sin nx, because by partial below first function as it is, integration of second minus differentiation of first into integration of second whole integration as the rule of by partial. So we are doing by partial. But sin nx integration is minus cos nx upon n. Right? And this is minus sign here, but it will be plus sign. That will be that later. But first differentiation of this cos nx will be n first power will come before, will be cos raised power n minus 1 x. Alright, this cos x is again differentiated to the minus sin x. Try to understand. Into this sin nx is cos nx minus cos nx upon n. Integration of sin nx here. It is sin nx into dx. It is triple negative, minus. Okay, it will be still negative. Keep it again. It is cos nx upon n minus sin m upon n. Son of integration. This is cos raised power n minus 1 x into sin x into cos nx into dx. Again, this is for, now let me take this for integration, now for differentiation. If I take these two as differentiation, which is cos nx as integration, let me take these three separately. This is first equation. And let me integrate these two. Sin x, cos nx. Okay, and what is cos m with power m minus 1 x sin x cos nx. If I write sin x cos nx something, okay, let me find out some cos nx sin nx. The integration here, integration of cos raised power n minus 1 x into sin x into cos nx into dx. If I write sin x cos nx something else, now we know that sin n minus 1 into x sin a minus b, this is nx minus x equal to what? It will be sin nx into cos x. Try to understand. Minus sin. It will be cos of nx into sin x. What do we see here? This is the value cos nx sin x. In place of these two, I mean this one. If I keep these two, that will be separate. Let me keep this. This implies that take this step this side. It will be cos nx into sin x is equal to sin nx into cos x minus sin of n minus 1 into x. Okay. In place of this step, these two multiplication, we can add these two separate values. Let me write it here. Therefore, this can be written as sum of integration cos raised power n minus 1 x in bracket these two values. It is sin nx into cos x, into cos x minus sin, this is sin n minus 1 into x, okay, into dx no problem. Now if I multiply this step into separate one, so what it will be? It will be sin of integration. This is cos of n-1 x into cos x. This one cos x. Cos x, if I multiply this with cos mx only, it will be only cos mx, because cos x in cos n-x with cos mx only, it is sin nx only minus into dx minus sin. This is multiplied with this. This is nothing but cos of n-1x into sin n-1 into x. That means it is phi n-1, n-2. Okay, this is a reduced formula. This is a reduction of this formula. Now this is the same value in cos mx and sin mx. Same value it has come up. So let me write these two values in place of first question. This is equation number second. Okay. So from second equation, the value of these two values, let me keep there. So putting the value of the second part integral from first and second we can write from first and second, substituting the value of from second to first, the value of integral from second to first, we get what will we get here? Substitute the value from second to first. Let me write it here. So what do we get here? We get IMN. Let me write symbol C. IMN MN is equal to this value. This is minus sin minus cos nx upon n. Okay. With this one, there is minus sign. I want it written down here. The minus sign here, sorry. The minus sign here. Okay. Then this minus sign, we got triple minus sign there, so this was negative. The minus sign here, it was m upon n. So let me have these two values. M upon n. So this is without this value, this mn. That means I n n. The IM minus m upon n. Okay, so this is m upon n only. M upon n. Okay, here also m upon n, negative sign. No, this is plus sign here. Because in between, this is minus, no problem, with minus sign. This minus sign it is negative, but this is plus sign. Plus sign. M upon n, this is m upon n here, here also m upon n. So this is I, m minus 1, n minus 1, right one is this is IMN, this is IMN. Take this IMN to this side. What do we get? The reduction formula. Now this is reduced, degrees are reduced, angle is reduced, degree is also reduced, n minus 1, angle is reduced by n minus 1. This is reduced or formula, reduction formula. Finally we get what the reduction formula is. What we get here, this n plus n, that means it will be n plus n upon n. If I add 1 plus m upon n, 1 here, this is plus m upon n, it will come to this side, so it will become plus sign. It will be 1 plus m upon n, that means m plus n upon n. So m plus n upon n into I mn is equal to minus sign cos raised over nx cos nx divided by n minus sign this plus sign, it will be m upon n I n minus 1 and comma n minus 1. If I divide this n will be cancelled out, dividing by n plus n, therefore I n is equal to minus cos raised to power nx into cos nx divided by n plus n. This is n plus n here. Plus sign, this is n upon n plus n I n minus 1 and n minus 1. N minus 1. Let me write it clearly in terms of integrals. That will be clear then. What is the final reduction formula? Let me write it. Sin of integration, this is cos raised to power nx sin nx dx is equal to minus sin, this is cos raised to power nx cos nx divided by n plus n plus m upon n plus n. Okay, the sin of integration, this is cos raised to power n minus 1 x sin angle n minus 1 x dx. This is dx here. This is a reduction formula for this function because the degree is reduced to this reduction formula. Repeated common use of this formula we can get. Okay, we can use this successively in a repetition manner. This is what reduction formula is. This is reduction formula question number. But similarly, you can get reduction formula for this question. What it will be that we write here. Similarly, we can get the question number 6 reduction formula for question number 6. Similarly, we can get the reduction formula for question number 6 here. Question number 6, that is for integration. Try to understand now this. This is mx sin nx cos nx dx. What it will be that we write.